these two types of division are going to get used like sporadically throughout the year. Like we're going to do it obviously in this section, but it's one of those things that's just going to keep coming back because you use these in different ways, okay? But this is how we divide polynomials. So you could get something that's just like an x to the third divided by something like x, or you could get different kinds. It could be a monomial on the bottom, but what you're dividing by determines if you can do synthetic or long division. You can do long division on any division, but it is long, thus the name. Synthetic is much faster and easier to do, but you can only do it certain times. So when we get to synthetic, I'll kind of establish the difference between them. Long division, and again, it's like obviously a lot of words that we're going to apply, and when we apply it, it will be easier. But it's hopefully just like if you get stuck in the process, you can revert back to this slide. The very first thing you do, and this is for both long and synthetic division, is arrange the terms of both the dividend, which is you're dividing into, and the divisor, which is what you're dividing by, in descending powers of the variable. So if the highest exponent is x to the fourth, it goes first. And then you have to have a term for every single x to the power. So if I have a 0, let's say I have an x to the fourth, and then I don't have anything again until x to the second, and then I have an x, and then I have a number. Anything that's missing, so any exponent that's missing, in this case we're missing an x to the third, you would plug in its place a 0 x to the third. Any term that's missing. So from highest exponent down to none, you have to plug in those, and these are placeholders. You're going to see why these are important. Good morning, sir. Good morning. Then you're going to divide the first term of whatever's on the outside into the first term what's on the inside, just like you would divide a numeric long division. Multiply every term in the top, or multiply every term on the outside by what's on the top, what we just divided by. And then you, instead of subtracting like we do with long division, we're going to change the signs and add the like terms. We do this just because people make mistakes when they start to subtract negatives, okay? There's no other reason other than that, just to avoid mistakes. So you change the signs and add. And then you would bring out the next term and repeat the process again, just like you would do with long division with a number. You repeat that until the remainder can no longer be divided into what's underneath. And then our answers are going to be quotient plus remainder over divisor. So it's going to be the top, whatever's on the top of the division bar, plus the remainder over what we divided by. All right, now we're going to put it into words. And it might be confusing at first, okay? So just take a deep breath, and I promise you it gets easier the more you practice it. So number one, we are going to look at my numerator. Is it in order from highest degree down to none? Yes. Are there any terms missing? No. I have a second. I have an x to the second, an x to the first, and then a constant. Then I do the same with the bottom. Is it in order of highest degree down to none? Yes. Am I missing any terms? No. So then I'm going to take the whatever's on the top, that x squared minus x minus 2. It goes under my division bar, just like I would with numbers. And the x plus 1 goes on the outside. So the top is called the dividend. The bottom is called the divisor. We are dividing the first by the first. So what would I have to multiply x by to get to x squared? X, and that's what I'm going to put at the top. So to figure out what goes at the top, I only look at the first in each. I don't even worry about the second yet. Now I'm going to take what's at the top and multiply it by both terms on the outside. X times x gives me an x squared. X times 1 would be a positive x. Then I would normally subtract, but again, people make some weird mistakes when you start to do this. So instead, we're going to change our signs and add, because that's the same thing as subtracting. If you've done it correctly, the first term should cancel out. Negative x minus x is negative 2x. Then we bring down the negative 1, or negative 2. And I repeat the process. So I do first and first again. What would I have to multiply x by? Hang on. What would I have to multiply x by to get to negative 2x? Negative 2. And then I multiply it times, just wait till I get all the way through if you can. Otherwise it's confusing to stop. Multiply it by the x, so negative 2x, and multiply it times the 1, negative 2. And then we change our signs and add. These cancel and these cancel, so my remainder is 0. The quotient is what's at the top. So the answer to this division question is just x minus 2. All right, question 2, same first step. Are they in order? Are they missing any terms? And neither. So I write the top one underneath. I put the bottom one on the outside. And then it is first and first. So what would I have to multiply x by to get to x squared? X. I'm going to multiply it times both. So x times x is x squared. X times 3 is positive 3x. Change the signs and add. Positive x and negative x are going to cancel out. Positive x squared, negative x squared are going to cancel out. Negative x minus 3x becomes what? Negative 4x. And then I bring down the next term. And I do first and first again. So what do I have to multiply x by to get to negative 4x? Negative 4. And that gets multiplied. Yep.
What did you do the first and first with negative 4? So did you do that?
I have to figure out what I have to multiply the first term on the outside by to get the first term underneath. And then I multiply that times both. So negative 4 times x is negative 4x. Negative 4 times positive 3 is negative 12. Change your signs and add. These cancel like they're supposed to. Negative 2 plus 12 is 10. And that's my remainder. Yep.
How'd you get the negative 12?
I multiply this times both terms. So it got multiplied by the x and it got multiplied by the 3. So, sorry, is quotient, which is x minus 4, plus the remainder, which is 10, over the divisor, which is what we divided by. So this is the format when there's a remainder. We're just going to keep doing it. Step 1, are they in decreasing degree order? Is anything missing? Yes, they're in order. No, nothing's missing. So that 5x to the third minus 6x squared minus 28x minus 2 goes underneath the bar, and x plus 2 goes on the outside. And it's first and first again. So what would I have to multiply x by to get to 5x to the third? Good. 5x to the second is going to get multiplied times the x. So I get 5x to the third and positive 2. So it's positive 10x squared. Then we change our signs. These cancel. Negative 16x squared minus 28x. Repeat the process. What would I have to multiply x by to get to negative 16x squared? Negative 16x. So I get negative 16x squared minus 32x. Change my signs. These are supposed to cancel, and they did. Negative 28 and positive 32 would be a positive 4x. And I bring down the next term. Repeat it again. What would I have to multiply x by to get to 4x? So I positive 4 multiply that by both terms. 4 times x, 4 times 2. But then I change my signs. These cancel, and negative 10 is my remainder. So my answer is 5x squared minus 16x plus 4. Now that negative, this would be a plus a negative 10 over x plus 2. So instead of the negative being in the top, we pull it out and we put it out front. So it's a minus 10 over x plus 2. Okay, so what's different with this one? Good, there's terms missing. So remember, we have to plug something in for each term missing. I have to rewrite this. So this is x to the third. There is no x to the second, so I have to put a plus 0x to the second. There is no x to the first, so I put a plus 0x to the first, and then minus 1, all over x plus 1. If the denominator is missing terms, I do the same thing. So if the denominator said x squared plus 1, I'd also do the 0x in the denominator. So both of them have to have the placeholders. If you don't do this, then when you go to multiply it out and you go to combine your terms, they won't combine because they're not the same exponent. So it will stop you. So I get x to the third plus 0x to the second plus 0x minus 1 divided by x plus 1. And first, what do I have to multiply x by to get to x to the third? X squared. And I multiply it times x, I get x to the third, and I multiply it times 1, and I get positive x squared. Then we change our signs. X to the third and negative x to the third cancel. 0x squared minus x squared is what? Good. Negative x squared, bring down the next term. Repeat your process. What do I have to multiply x by to get to negative? God bless you. Negative x squared. Good. And we multiply it times both. Negative x squared, negative x. Change your signs and add. First ones cancel. 0x plus x is x. Bring down the minus 1. And last time, first into first. What do I have to multiply x by to get to x? Positive 1. Multiply it times both. Change your signs. The first ones cancel. My remainder is negative 2. And then I rewrite the top. So x squared minus x plus 1 minus 2 over x plus 1. So we pull the sign, if it's negative, we pull the sign off the remainder and put it in between. That long division can be done every single time. Synthetic division, which looks like it has the same amount of steps, but I teach math for a living, so I'm a nerd, but synthetic can be fun. Synthetic is fast. We eliminate the variables. Remember when you were always like, why do we put variables and letters into math? This is where we go backwards, okay? And we just use the numeric values from our polynomial. But the catch is you can only do this when it is x plus or minus a number. You cannot do it when it is x squared. And even if there was something on the front of the x, there is a way to do it, but it gets complicated. I would say don't do it. Step 1 is exactly the same. Arrange the polynomial in descending powers with a 0 coefficient for any missing term. Yep.
What was the restriction again?
You can only do it if it's x plus or minus a number, not if it's x squared or if there's something in front of the x. Then we take, so let's say I'm dividing by an x minus 2. I change the sign on the 2 and I put it on the outside and I make this long-shaped L. And I list only the coefficients of all the terms in my dividend. so the thing at the top. Step 1 is bring down the first term, so it just gets brought straight down, and I write it underneath. Then I multiply what's on the outside by what's brought down, and I put it in the next column. And then I add those columns. And then I multiply what's on the outside by what's in the second column, and I put it in the third column. And I repeat this until I run out of numbers. The last number is your remainder. And then we go up from there. We go, the first term has no variable, just the number. The second number gets the x. The third number would get x squared and x to the third, and so on and so forth in increasing exponents. This is one of those things that takes practice, but I promise you if you practice it, this is super easy and it's quick. You just have to be careful with your signs. People make some interesting mistakes with signs. And we're going to use this in a bunch of different ways. So it's just straight up divide. And I know I can use synthetic because it's x plus or minus a number, not x squared. Look at both. Are they in descending degree order? Is any term missing? Good. So I'm ready to write them out. So I write just the coefficients, which would be a positive 1, a negative 1, and a negative 2. And then I make my L. And I put the opposite of what follows x. So a negative 1 goes on the outside. You'll also see it sometimes written like this. It's the same thing, okay? Sometimes they're just written different. Yep.
Where's the negative 1?
The opposite of what follows x. So what goes on the outside is always opposite of what follows the x on what you're dividing by. That's how we get rid of the subtract part of this. We change it there. So now we bring down the first term. I bring down the 1. I multiply the negative 1 times the 1, and I put it in the next column. That's negative 1. Then I add those two, and I get negative 2. And then I multiply what's on the outside by what's on the bottom. I get positive 2, and then I add them. The last number is my remainder. Moving left, the first one gets no variable. The second one would get x to the first. If there was another one, it would get x to the second. If there was another one, it'd get x to the third, and it would increase in degree as you move left. So my quotient is just x minus 2 with no remainder. Checking numerator, decreasing degree, anything missing. So it's good to go. My first row is going to be 1, negative 1, negative 2. Only the coefficients. Outside goes what? Negative 3. Change the sign on what follows the x. And then we bring down the first term. We multiply the outside by the bottom and put it in the next column. Then we add it. We multiply what's on the outside by the bottom and we put it in the next column. And we add it. This time, my remainder is 10. The negative 4 stays without an x. The 1 gets an x. So my quotient is x minus 4 with a remainder of 10. So plus 10 over my original divisor, which is x plus 3. Yep. No, it could be 0, like the last one was 0. Yeah. All right, same step 1. Is it in decreasing degree order? Yes, nothing's missing, so we list the coefficients. 5, negative 6, negative 28, negative 2. Draw your long L. Negative 2 goes on the outside. Bring down the 5. Multiply it by the negative 2. Put it in the next column. Add it. Multiply it by 2. Put it in the next column. Add it. Multiply it by negative 2. Put it in the next column. And add it. Last one is the remainder. 4 stays as 4. 16 gets the x. 5 gets what? X squared, good. So it's 5x squared minus 16x plus 4 with a remainder of negative 10. So minus 10 over x plus 2. Questions? Yeah.
When you multiply, what two numbers are you?
Outside, bottom. And I taught you how to like build, like once you to figure out your x and your x squared, I go right to left. You can also go left to right. The first x is gonna always have one less exponent than what you divide it into. So if it's x to the third, you can also start that way. It would be x squared and then x to the first and then no x and then the remainder. So if you wanna go left to right, you can. It's the same. If you look, we just did the same 3 questions using long division and synthetic division, okay? So both methods should produce the same answer. You can always go back and forth. Again, you can only do synthetic if it's just x. If it was x squared, I couldn't do synthetic. So like on your test, you're gonna have one of synthetic and one of long division. And the long division one can't be done using synthetic, so it's not like you can use the other method. All right, this time we're missing terms, yes? So we're gonna do it again where we plug them in as placeholders. So it'd be x to the third plus 0, x to the second plus 0, x minus 1 over x plus 1. And now we list the coefficients. So it would be 1, 0, 0, negative 1. Draw the bar. Negative 1 goes on the outside. We bring down the 1. Multiply it, put it in the next column and add it. Multiply by what's on the outside, put it in the next column and add it. Multiply by what's on the outside, put it in the next column and add it. Negative 2 is my remainder. I'll go left to right this time. So it's 1 less than the exponent on my original question. This gets the x squared, this gets the x, and the 1 is the constant. Sophia?
What'd you multiply by the negative?
You multiply what's on the outside by the bottom, and you put it in the next column. So I get x squared minus x plus 1 minus 2 over x plus 1. Questions so far? God bless you. Yeah.
So you can like do it this way as long as there's no x squared.
Correct.
So if it was like x to the third, x to the fourth.
You'd have to do long division.
Okay.
Yep. Okay, so now we're just going to literally use synthetic. Synthetic gets applied in a lot of different ways, but we're going to use it a couple different ways. So this one has to be long division. I'll start it to set up, but this one would have to be long division. I would do 2 x to the fourth plus 4 x to the third minus 5x squared plus 3x minus 2 divided by x squared plus 2x minus 3. Actually, I'll multiply it all the way out because again, it gets confusing. I cannot use synthetic on this one because it was x squared. So even though there's 3 terms on the outside, the process is still the same. I still do first into first. So what would I have to multiply x squared by to get to 2x to the fourth? 2x squared. Now I have to multiply it times 3 terms. So it goes by the x squared. I'd get 2x to the fourth it goes to the positive 2x, so positive 4x to the third. And it goes times the negative 3, negative 6x to the second. Then we change our signs. If you do it correctly, the first ones will cancel. Positive 4x to the third and negative 4x to the third also cancel. So this would be a 0x to the third if I wanted the placeholder, but you don't even need it. Well, not when you're doing this part. And then negative 5x to the second plus 6x to the second would be a positive x to the second. Now, when there's 3 terms, you have to bring down 3 terms. So there's one there. I have to bring down both the positive 3x and the negative 2. So 3 terms on the outside means I'm going to bring down 2 terms on the inside. What would I have to do first and first again? What would I have to multiply x squared by to get to x squared? Positive 1. And I multiply it times the x squared, I get x squared. I multiply it times the 2x, I get a positive 2x. I multiply it times the negative 3, I get a negative 3. And then we change our signs and add. The x squared and the negative x squared cancel out. Positive 3x and negative 2x becomes x. Negative 2 and positive 3 becomes positive 1. Now, is there anything I can multiply x squared by to get to x? No. When the exponent on the remaining part is smaller than the one on the outside, you're done. This whole thing is the remainder. We don't use negative exponents. That would be a nightmare. So my coefficient, or my quotient is 2x squared plus 1. I don't need the 0x on my answer. And my remainder, so plus x plus 1 over x squared plus 2x minus 3. Sophia?
How did you know that you were finished?
Because I can no longer, so one way is the exponent on the x is smaller than the one on the outside. But also just see, can I multiply something by x squared to get to be x? And the answer is no, not without a negative exponent, which we won't do. Okay, so again, we're going to learn how to apply that synthetic division in a couple different ways. The first is called the remainder theorem. And the remainder theorem says, which it's weird, that's like actual words of it. If a polynomial f of x is divided by x minus 3, then the remainder, oh, this should say equals f of k. And what this means is, if let's say I had given you an f of x and I said, find f of 3. Up till now, how would you have done that? If I said f of x was x plus 3, how would you have found that, f of 3? I would have plugged the 3 in for the x, okay? Which is one way to solve it. The other way to solve it is by using synthetic division, putting the number that's in the parentheses on the outside. It would be 1 and 3. Bring down the 1, multiply it by 3, put it in the next column, and add it. And grab just the remainder, and that would be the same answer. So when it says use the remainder theorem, that's what it means. Take that value, put it on the outside. This time we don't change the sign because that is the value. It's not x minus it. We put it on the outside. You do synthetic division, and the remainder of your answer is the answer to the f of whatever it is. You don't need any other part of it. Obviously, in a situation like this, it's probably faster to just do 3 plus 3. But when they get complicated, it's going to be easier to do it using synthetic division. So I'll do one of these, and then we'll go back and we'll save 11 for Monday. But it says find f of negative 2. So negative 2 goes on the outside. Make sure nothing's missing. It's in order, and list all your coefficients. Bring down the 3. Multiply by negative 2. Put it in the next column. Add it. You get 2. Multiply by negative 2. That's negative 4. Put it in the next column. Add it. You get 1. Multiply by negative 2. It's negative 2. Put it in the next column, add it, you get negative 9, and that's your answer. God bless you. This time, way faster than having to plug in a negative 2, and then cube it, and then multiply it by 3, and then square it, multiply it by 8, multiply by 5, and then combine all those terms. So this is called the remainder theorem. Again, I'll save 11 for Monday because it's the same kind of question. The factor theorem says a polynomial has a factor if and only if the remainder is 0. So if it gives you, it's either, you see this two ways. One, is x minus 2 a factor of this polynomial? And the answer is yes if the remainder is 0, and it's no if it's not. It's as simple as that. The other way you'll see it is this. It will say, here's my huge polynomial. X minus 2 is a factor. Find the remaining factors. And for those, you will take, so if it's x minus 2, I'm going to put 2 on the outside. So if it says x minus 2 is a factor. I put 2, opposite because it's x minus, on the outside. I do my synthetic division. My answer is going to be 0 because it is a factor. But then I take my remaining polynomial, so my quotient here, and I factor it to get the remaining zeros. So this is how you would find the zeros if they were not factorable. All right, I'm going to do this kind of fast because we just talked about it. But to determine if x minus 2 is a factor, I'm going to put a 2 on the outside. Because it's x minus, I change the sign. I list my coefficients. There's nothing missing, and they're in decreasing degree order. And I do synthetic division. Bring down the 2, multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. My remainder is a 0, which means this is a yes. Okay, so we're going to take the factor. Because it's x plus 3, this is when we change the sign, so it's minus 3 on the outside. We're going to take our polynomial. This time we're missing an x squared, so it's going to have a 0x squared. 1, 0, negative 19, and negative 30 are our coefficients and constants. Bring down the 1. Multiply by negative 3, put it in the next column and add it. Multiply by negative 3, put it in the next column and add it. Multiply by negative, or add it, you get negative 10. Multiply by negative 3, you get 30. And 0 is your remainder. If this is not 0, then you did something wrong because it's telling you it's a factor, which means that has to be 0. So then the negative 3 gets the x, the 1 gets the x squared. And I get x squared minus 3x minus 10. Now at this point, what is left, because we haven't used the graphing utility, what is left will be factorable. So then we're going to factor this, x minus 5x plus 2. There's our remaining factors. So the factors are x plus 3, x minus 5, and x plus 2. And the zeros would be to solve each of those. So negative 3, positive 5, and negative 2. So if it asks for zeros, you're listing your answers by solving each of those parentheses, setting them equal to 0. If it's asking for the factors, then you're going to put them behind the x's. So the signs change and you leave it as though it was factored.